we are going to discuss numerical for second chapter, that is mechanical properties of fluid. In this case, we have been given that first question, find the pressure 200-meter below. So height is given to you. Height is given to you. H is given to you as 200 meter below the surface of an ocean. ओशन के एक सरफेस है, उससे नीचे 200 मीटर के हाइट पे पता करना है, प्रेशर पता करना है. If the pressure on the free surface of liquid is 1 atmosphere, please remember students, surface पे जो pressure आता है, that is called as an atmospheric pressure, and they have been given that atmospheric pressure for that particular ocean का surface is 1 atmosphere. In last I have told you 1 atmosphere कितना होता है, 1 atm. So that is P naught is given to you, that is 1 atm. 1 atm is 1.013 into 10 raised to 5 Pascal. You have to remember this value. 1 atm value is 1.013 into 10 raised to 5 Pascal. This is the 1 atm value. You need to find the pressure at a height. Pressure height पे पता करना. To find the pressure, we have relation which is given to us. P is equal to P naught plus H rho g. अच्छा, rho is also given to us. Rho is given 1060 kg per meter cube. So rho is given to P equal to P naught plus H rho g. ये हमारा फॉर्मूला है, P equal to P naught plus H rho g. So P पता करना है. P naught is 1.013 into 10 raised to 5 plus H का value is given as 200 into 1060 into take G as 10. So when you solve this, you get 1.013 into 10 raised to 5 plus this value. When you solve, you get 20.7. 20.7 into 10 raised to 5 आना चाहिए value. Now what will you do? 10 का power 5 common कर दो. 1.013 plus 20.7. That will be 21.789. Nearly this will be your answer. Newton per meter square or Pascal. Newton per meter square and Pascal is one and the same. So 10 का पावर 5 लेके you get this value. दोनों values को add कर दो, ये आंसर आएगा. Next, in a hydraulic lift is an application of Pascal law, students. Hydraulic lift as application of a Pascal law. The input piston head area is given to you. Suppose the first area is given 30 centimeter square, and the output piston has a surface area of 1500 centimeter square. So there are two areas given to you. One is 100, other one is 1500 centimeter square. So I can say, suppose A2 is given to me. A2 is given to me as 1500 centimeter square. If a force, one force is given 25 Newton is applied to the input piston, calculate the weight on the output piston. Second wale ka force, weight means force. Second wale ka force pata karna. So we know that from applications of Pascal law, hydraulic lift ke liye we have F1 upon F2 equal to A2 upon A1. This is inversely related to each other. Or if you do not know this formula, you might be aware of F1 upon A1 equal to F2 upon A2. Okay, let us use that one. It is one and the same. So let us use the second formula that is given to you. That is F1 upon A1 equal to F2 upon A2. So from here I can say F2 will be equal to F1 into A2 upon A1. So therefore F2 will be equal to F1 कितना दिया हुआ है? F1 is given to as 25. A2 is given to you as 1500 divided by A1 is given to you as 30. I'm not converting here centimeter square because if you see ये दोनों रेशियो में आएगा, तो रेशियो में वो सेंटीमीटर स्क्वायर कट ही होने वाला है, उसका कन्वर्जन भी कट होगा. ठीक है. So when you solve this, you get the value of F2. So the value of F2 will be 1250 Newton. 1250 Newton. That's it. So this is the second value. Next, calculate the viscous force acting on a raindrop of diameter is given to you 1 millimeter. 1 millimeter, so 1 into 10 raised to minus 3 meter. Please know that millimeter का conversion is 10 raised to minus 3. Radius निकाल लो 0.5 millimeter. I have always told students whenever diameter is given to you, always find the radius. कहीं ना कहीं तो उसका यूज आ ही जाएगा. ठीक है. So 0.5 into 10 raised to minus 3 meter. Falling with uniform velocity is given to you. V is given to you 2 meter per second through air. The coefficient of viscosity eta is given to you 1.8 into 10 raised to minus 5 Newton second per meter square. Find the viscous force. The question is asking find the viscous force. Viscous force matlab F. If you see the given things, you can use Stokes law to find. So using Stokes law, you get F equal to 6 pi eta RV. That is the formula for Stokes law. F is the viscous force, वो पता करना है. 6 into 3.14 into eta का वैल्यू 1.8 into 10 raised to minus 5 into radius का वैल्यू 0.5 into 10 raised to minus 3 into velocity का वैल्यू 2. So when you solve this, you get the value for viscous force 33.912 into 10 raised to minus 8 Newton. When you substitute the value and solve, you get the viscous force F equal to 33.912 into 10 raised to minus 8 Newton. That is the answer. Next, a horizontal force of 1 Newton. Again, so F is given to you as 1 Newton is required to move a metal plate of area is given 10 raised to minus 2 meter square with velocity is given to you 2 into 10 raised to minus 2 meter per second. When it rests on a layer of oil, okay, layer of oil, तो इसका thickness दिया है, thickness 1.5 into 10 raised to minus 2. I will write thickness as dx meter. Find the coefficient of viscosity. We know that velocity gradient हमने पढ़ा है क्लास में, चैप्टर में we have studied velocity gradient. एक टर्म होता है velocity gradient होता है dv upon dx. इसके लिए यहाँ पे मैंने velocity को v and dx लिखा है, dv and dx. Using velocity gradient का formula, we have eta का formula, we have coefficient of viscosity का formula, eta equal to f upon a. Okay, in other words I can write, तो numerator में लेना है f, this will be f upon a into velocity gradient, that is dv upon dx. That is the formula. Now put the value. F is 1 upon area 10 raised to minus 2. dv is 2 into 10 raised to minus 2 upon dx का value 1.5 into 10 raised to minus 2. So 10 raised to minus 2 cut हो जाएगा यहाँ से. So when you solve this, you get the value for eta. The value for eta will be 7.5 Newton second per meter square. Students, please remember the units. Units are very, very important. So units are necessary. So when you solve this value, you get 7.5. Very, very important. The next question is, with what terminal velocity you are supposed to find the terminal velocity v when an air bubble of 0.4 millimeter in diameter. Diameter is given 0.4 millimeter, converted to radius 0.2 millimeter, again 0.2 into 10 raised to minus 3 meter. In diameter will rise in a liquid. Very important word, rise in a liquid of viscosity is given to you 0.1 Newton second per meter square with a specific gravity is 0.9. Students, please remember specific gravity. It is also called as a relative density. कुछ लोगों को relative density के बारे में पता होगा. If you don't know what do you mean by relative density or specific gravity, that is density of substance divided by density of water. It should always be divided by density of water. Density of that substance is divided by density of the water. This is called as specific gravity or relative density. So this is known to you that specific gravity, ये specific gravity का formula है. Specific gravity को relative density भी बोलते हैं. ये formula है density divided by density of water. So they have been given that specific gravity is given to you 0.9. So इससे density निकाल लो. Density rho जो है rho का value निकाल लो. Rho का value कितना हो जाएगा? Specific gravity into density of water, बराबर है ना. एंड डेंसिटी ऑफ वाटर, स्टूडेंट्स प्लीज रिमेंबर, डेंसिटी ऑफ वाटर इज 10⁻3. ये दोनों मल्टीप्लाई हो जाएगा ना. डेंसिटी ये निकालने के लिए ये दोनों को आपस में मल्टीप्लाई करेंगे, राइट. स्पेसिफिक ग्रेविटी इनटू डेंसिटी ऑफ वाटर विल बी द डेंसिटी. सो रो विल बी इक्वल टू 0.9 into 10⁻3. प्लीज रिमेंबर द डेंसिटी ऑफ वाटर इज 10⁻3. ठीक है, that is 1000. 0.9 into 10⁻3, so that will be equal to 900. इसको सॉल्व करो तो 900 आ जाएगा kg per meter. ये हमने अभी डेंसिटी निकाला है, अभी आंसर नहीं हुआ है. डेंसिटी ऑफ एयर इज गिवन टू इन द क्वेश्चन. डेंसिटी ऑफ एयर, उसको सिग्मा ले लेंगे 1.29 kg per meter. पता क्या करना है? टर्मिनल वेलोसिटी. टर्मिनल वेलोसिटी का फॉर्मूला 2/9. द टर्मिनल वेलोसिटी फॉर्मूला 2/9 r² g रो माइनस सिग्मा डिवाइडेड बाय ईटा. ये फॉर्मूला है टर्मिनल वेलोसिटी. तो 2/9 तो नंबर है, वो तो ऐसे ही रहेगा. आर स्क्वायर, आर इज गिवन टू यू 0.2 into 10⁻⁻3. उसका वैल्यू सब्स्टिट्यूट करो. जी वैल्यू यू कैन टेक 9.8 and then rho minus sigma 900 minus 1.29 into eta का value is also given to you. So when you solve this, you get the answer as 0.782 into 10⁻³ meter per second. The answer will be 0.782 into 10⁻³ meter per second. The speed of a water is 2 meter per second. So first speed they have given v1, let us assume this is v1, 2 meter per second, through a pipe of internal diameter is given to you. Suppose d1 10 centimeter is given to you. What should be the internal diameter? सेंटीमीटर को मीटर में कर लो. अगेन रेडियस है, रेडियस निकाल लो इससे 5 सेंटीमीटर, 5 into 10 raised to minus 2 meter. What should be the diameter? Second diameter पता करना है. अच्छा diameter पता करना है, ठीक है. So let us do one thing. Let us do not substitute radius. We will use diameter only. इस diameter पता करना है. Second speed is given, v2 is given 4 meter per second. So we know equation of continuity. Using equation of continuity, equation of continuity states that a1 v1 equal to a2 v2. एरिया नहीं दिया है, एरिया इज पाई आर स्क्वायर. ठीक है, पाई आर वन स्क्वायर वी वन इक्वल टू पाई आर टू स्क्वायर इंटू वी टू. पाई पाई कैंसिल. रेडियस को डायमीटर के टर्म्स में करो, तो डायमीटर का हाफ होता है ना रेडियस, तो डी वन अपॉन टू द होल स्क्वायर इंटू वी वन इक्वल टू डी टू अपॉन टू द होल स्क्वायर इंटू वी टू. टू टू कैंसिल, तो डी वन स्क्वायर वी वन इक्वल टू डी टू स्क्वायर वी टू. वी नीड टू फाइंड आउट डी टू, तो डी टू स्क्वायर विल बी इक्वल टू डी वन स्क्वायर वी वन अपॉन वी टू. तो सब्स्टिट्यूट द वैल्यू, d1 स्क्वायर v1 अपॉन v2 का वैल्यू सब्स्टिट्यूट करो. d1 स्क्वायर इज v1 का वैल्यू 10 into 10 raised to minus 2, that is given to you. v1 का वैल्यू is given to you 2 meter per second, and we have been given v2 का वैल्यू is also given to you. So when you solve, you get this as 7.07 into 10 raised to minus 2 in meters. meters में मिलेगा 7.07 into 10 raised to minus 2. With what velocity v you are supposed to find, with what velocity the water flow out of an orifice. Orifice means hole or a leakage, something. Gauge pressure is given to. Gauge pressure means pressure difference. So suppose P2 minus P1 या P1 minus P2, कोई भी दो प्रेशर्स के डिफरेंस को गेज प्रेशर बोलते हैं. Suppose that is given to you. On solving this, you get 4 into 10 raised to 5. This has been given to you. Gauge pressure is given to you 4 into 10 raised to 5. As I told you, the gauge pressure means the pressure difference. So what should be the velocity and density is given to you? Density of water is given to you as 1000. 1000 means 10 raised to 3, as I told you earlier. 1000 kg per meter cube is given to you. There are two formulas which you can use to find the pressure. We know that gauge pressure P2 minus P1 equal to rho Hg. This is the formula to find the gauge pressure. So P2 minus P1 is given to you, rho is given to you, G value we know, H is not known to us. So the very first thing that we will find out from this particular case is the value of H will be required for you to find. From H, first you find H, then you find velocity. Because velocity, the formula is root 2gh. Torricelli's law, speed of efflux, we have done. Torricelli law or speed of efflux, we know that velocity is equal to root 2gh. So H we will have to first find. So H will be equal to P2 minus P1 upon rho g. P2 minus P1 will be 4 into 10 raised to 5 upon 1000 into 10. You can assume it as 10. So H will be equal to 4 into 10 raised to 5. Denominator will be 10 raised to 4. So when it goes in the numerator, it will be 10 raised to minus 4. 4 into 10 raised to 5 into 10 raised to minus 4 will be 40. So height will be 40 meters. So substitute the value, v will be equal to root 2 into 10 into 40. So when you substitute and take the square root of this number, you get 28.28 meter per second. Okay, this will be 28.28 meter per second as the answer. Next, again it is a similar sum. The pressure on the water inside a closed pipe is given to you. So this is the first pressure given to you. So suppose P1 is given 3 into 10 raised to 5 Newton per meter square, and second pressure is given to you 2 into 10 raised to 5 Newton per meter square. Calculate the speed. Same formula you are supposed to find जो पिछले sum में किया था. So again density is given as 1000. So here you will do P1 minus P2. As I told you, if you write P1 minus P2 or P2 minus P1, it will not make much effect. So that will be equal to rho Hg. So H will be equal to P1 minus P2 upon rho g. So when you solve this, you get the value as P1 minus P2 will be 1 into 10 raised to 5 divided by 10 raised to 3 into 10. So that will be 1 into 10 raised to 5 divided by 10 raised to 4. So this will be just 10 meters. So use V equal to root 2gh. So V will be equal to root 2 into 10 into 10. So V will be equal to 10 root. That is 10 into 1.414. That is 14.14 meter per second. This is the velocity answer. Calculate the rise of water inside a clean glass capillary tube. Height you are supposed to find. With the radius is given to you 0.1 millimeter. Radius of the capillary tube 0.1 into 10 raised to minus 3, or I can say 1 into 10 raised to minus 4 meter also. When immersed in a water surface, tension is given to 7 into 10 raised to minus 2 meter. The angle of contact is 0. The density is given as 10 raised to 3. Take G as 9.8. Now, since they have mentioned, you will have to take it as 9.8 only. We know that height equal to 2t cos theta upon r rho g. This is the formula. To find the height or rise of a liquid in a capillary tube, H is equal to 2t cos theta upon r rho g is the formula. So when you use this equation, 2t cos theta upon r rho g, when you substitute the values, you get, I'm directly writing the answer 0.142 meter. That will be your answer. Everything is given to you. You just need to substitute the values and solve direct formula based questions. An air bubble of radius is given to you 0.2 millimeter. 0.2 means 2 into 10 raised to minus 4 meter. Situated just below the water surface. Calculate the gauge pressure. Gauge pressure, as I told, P1 minus P2, you are supposed to find. Surface tension is given 7.2 into 10 raised to minus 2 Newton per meter. So gauge pressure for a bubble, air bubble. Na? In case of bubble, we have done Laplace's law of spherical membrane. So there we have seen the pressure difference will be equal to 2T by R. We have done this derivation. Laplace's law of spherical membrane, or excess pressure inside the liquid drop. So the pressure on the left hand side we are supposed to find. So therefore P1 minus P2 will be equal to 2 into T ka value 7.2 into 10 raised to minus 2 divided by R value is 2 into 10 raised to minus 2. This will get cancelled. P1 minus P2 will be 7.2 into 10 raised to 2 is Newton per meter. So that will be 720 Newton per meter square. In the textbook, the answer is wrong. They have given 7200. That is wrong. It will be 720 only. 27 droplets of water, each of radius 0.1 millimeter. 27 droplets of water, each of radius 0.1 millimeter is given. The number of droplets is given 27. Radius of small drop is given 0.1 millimeter. I can write it as 1 into 10 raised to minus 4. Collapse into a single drop. Find the change in surface energy. That means work done. Change in surface energy means work done. Change in surface energy means work done. If the surface tension of water is given 0.72, so I can write this as 72 into 10 raised to minus 3 Newton per meter also. 72 into 10 raised to minus 3 Newton per meter. Please remember, students, I'll give you one formula here. The formula is not mentioned in the textbook, but there are two sums, sum number 20, sum number 21. These are two similar type sums. The formula is not given to us. So I'm directly given you the formula. Whenever there is a word collage given, collage means combination. Collage means combination. When the molecules combine to form a single drop, the work done is given by, I'm writing the formula. The work done in that case will be given by 4 pi n raised to 1 by 3 r square t n raised to 1 by 3 minus 1. This is our formula. The work done, you will have to directly remember this formula. This is a very helpful formula for entrance also, because we have similar type questions in entrance. Mostly in CET, they have asked this type of questions. Work done will be equal to, work done means surface energy, that will be equal to 4 pi n raised to 1 by 3 small r square, the whole square, into t n raised to 1 by 3 minus 1. Please remember, n raised to 1 by 3 is a cube root of the number which is given to you, the cube root of a number. So that will be, W will be equal to 4 into 3.14 into 27 cube root into 1 into 10 raised to minus 4 whole square into t, surface tension T, 72 into 10 raised to minus 3 into 27 cube root minus 1. Please remember, 27 cube root is 3. So 4 into 3.14 into 3 into 1 into 10 raised to minus 4 the whole square into 72 into 10 raised to minus 2 into t 3 minus 1. So when you solve this question, on solving these particular values, you will get the final answer. So the final answer will be 0.162. I will write the final answer. 0.162 into 10 raised to minus 6 joules. This is your final answer. You just solve this multiplication karo, you will get the answer 0.162 into 10 raised to minus 6 joule. That is your answer. Similarly, we have next sum. Now here it is reverse of the previous one. In the previous question, we had many droplets getting converted into single drop. Here one drop is broken. Here if you see here it is broken. In last case it was combination. You have combined the drop into single drop. यहाँ पे एक बड़ा drop छोटा drop में convert हो रहा है. ठीक है. Broken into 8 drops. So n is given 8 drops. The radius of the big drop is given 0.2 centimeter. So that is 0.2 into 10 raised to minus 2 meter. That is 2 into 10 raised to minus 3 meter. Find the work done. Again, for find the work done, surface tension is given 435.5 dyne per centimeter. You have to convert dyne per centimeter to Newton per meter, multiply by 10 raised to minus 3. Okay, please remember 1 dyne per centimeter is 10 raised to minus 3 Newton per meter. Just remember this conversion value. Here the formula will be 4 pi capital R square T n raised to 1 by 3 minus 1. Here the formula will be 4 pi capital R square T n raised to 1 by 3 minus 1. So now substitute the value 4 into 3.14 into R square, that is 2 into 10 raised to minus 3 square. T 435.5 into 10 raised to minus 3 n raised to 1 by 3. 8 का cube root. 8 का cube root is 2. Remember 8 cube root. 8 raised to 1 by 3. इसको solve करेंगे तो 8 cube root is 2. So 2 minus 1. So when you solve this, you get the final answer as 218.54 into 10 raised to minus 7 joule. That is your final answer. 218.54 into 10 raised to minus 7 joule. Last two sums. How much work is required to form a bubble of radius is given 2 centimeter. So 2 into 10 raised to minus 2 meter to form a soap solution having surface tension 0.07 Newton per meter. So I can write it as 7 into 10 raised to minus 2 Newton per meter. Work done मतलब surface energy. We know that surface energy के लिए T into dA, T into change in surface area. This is a derivation. Surface energy and surface tension में relation है. Surface energy is T into dA. dA into T, but since when it is a soap solution, you will write 2TA into D. I have told in the derivation also, you have been written surface energy is 2TA into dA. Whenever there is a soap solution, you will add a multiple of 2. Soap solution नहीं रहेगा तो सिर्फ T into dA करना. So W will be equal to 2 into 7 into 10 raised to minus 2, 4 pi R square, because it is a bubble, na? Bubble is spherical in shape, right? So W will be, this is 14 into 10 raised to minus 2, 4 into 3.14 into R square, इसका square होगा 4 into 10 raised to minus 4. I have directly written the square value. So when you square that term, you will get 4 into 10 raised to minus 2. So that's it. You just need to multiply these values, and on multiplying, you will get the final answer that is given. Next. A rectangular wire frame of size 2 centimeter into 2 centimeter is given. So here there are two areas which are given to you, 2 centimeter into 2 centimeter. So I'll write this as first area, A1. So this I can write 4 centimeter square, that is 4 into 10 raised to minus 4 meter square. In a soap solution, again this is a soap solution, and taken out, a soap film is formed if the size of the film is changed to 3 centimeter into 3 centimeter. So A2 is given 3 centimeter into 3 centimeter, that is 9 centimeter square, that is 9 into 10 raised to minus 4 meter square. The surface tension is given to you 3 into 10 raised to minus 2. Calculate the work done. Again, as I told you, work done means surface energy. So we know that work done is 2T into dA. Now whenever there are two areas given, dA will be A2 minus A1. So 2T into A2 minus A1. So W will be equal to 2 into 3 into 10 raised to minus 2. Area A2 is 9 into 10 raised to minus 4 minus area A1 is 4 into 10 raised to minus 4. So W will be equal to, this will be 6 into 10 raised to minus 2 into 9 minus 4 is 5 into 10 raised to minus 4 common. 5 6 are 30. 30 into 10 raised to minus 6. That is your answer. 30 into 10 raised to minus 6. So these were the problems in case of mechanical properties of fluid. This was a last numerical.